Hello grade 7s, welcome to today's natural science video lesson. I hope you all are well, and today we're going to be starting a new section on potential energy. So we're not going to go too crazy here in grade 7, we're just going to be focusing on potential energy and kinetic energy. So you'll find this section on page 112 of the textbook. And I'm just going to go through a little bit of the theory here. I'm going to write some notes on the whiteboard, and feel free to copy these notes in your books as a summary. So before we continue, I just wanted to recap our definition of energy. You'll find this a few pages back in the keywords. It says that energy is the ability of a system to do work. So this is quite a broad definition, and it encompasses all different kinds of systems and all different types of energies. So for example, we could think of our bodies as a system, and if we get enough food and proper nutrition, then our bodies have the ability to do work, either physical work or mental work. As another example, we could think of this very simple system of the whiteboard marker, whiteboard duster, and if I was to throw it, this object would gain energy called kinetic energy when it's moving. The harder I threw it, the more kinetic energy it would gain, and it has the ability to do probably some destructive work, like either smashing the window or making a loud noise. So yeah, let's now jump into the theory for this section, potential energy. And the first one we'll look at is elastic potential energy. So it's very simple to understand. When we stretch the rubber band, we are giving it potential energy. It has the potential to do something, and if I was to release it, it would fly away. Now, the more I stretched it, the more potential energy I'd give it, and the further it would fly. A similar example is a bow and arrow. So as you draw the arrow, the bow curves and it gives elastic potential energy, and the further you pull, the further the arrow will fly. So next up, we're going to talk about gravitational potential energy. And this is quite a simple concept to understand. It's related to the energy in falling objects. So if I took my cell phone and I raised it a little distance above my keyboard and dropped it, nothing happens. However, if I was to raise the phone higher and drop it, chances are either my phone or my laptop or both would break. So what does this tell us? It tells us that the higher we raise an object, the more gravitational potential energy it has, and when it's released, when the object is released, the harder it falls. So another example related to this are water reservoirs. You may have seen these standing against the skyline in Johannesburg, and these are tanks built up on stilts high up in the air. Inside each of these tanks is water. Now you might be wondering, why do they store water like this? Why do they store it so high above the ground? And the reason is because of gravitational potential energy. When this water is released, when the valves are open, the water, by the time it reaches ground level, shoots out very fast. The water falls harder the higher it is, and this buildup in water pressure is it's so that the water doesn't trickle out. So for example, if this was connected to a tap, you need a certain amount of pressure to force the water through the plumbing, or for something like firefighting, you don't want the water to trickle out the hose, you want it to spray as far as possible. So next up, we're going to talk about chemical potential energy. And once again, remember that with potential energy, it's stored energy, and it remains in that storage until it is utilized. The first example we're going to look at is food. And when we eat food, it can be converted into a number of things. It can give us kinetic energy, the energy of motion when we move. It can be converted to electrical energy for our mental functions, and the energy released from the food is also used to power certain chemical reactions which occur constantly through our bodies. The next type of chemical potential energy is fossil fuels, which we've seen already, and these fuels can be burnt to release thermal energy. Lastly, we have batteries, which is a very simple conversion to electrical energy. And we saw that with the motor, where the electrical energy was converted to magnetic energy, which was then converted to the motor spinning kinetic energy. So lastly, we need to speak about the metric unit for measuring energy. Energy is measured in joules, and that's given by a capital J. So this is similar to how we get other metric units. For example, length is measured in meters, or weight is measured in kilograms. So energy is just measured in joules. So we can commonly find this concept of joules when we're looking at food labels for the various food products. You can see this on page 134 of the textbook. So if you look there, you'll see this boy looking longingly at this Energade. Maybe he's really tired and he wants to see how much energy he could be getting from it. So usually the energy content is the very first thing on our food label. And here it tells us that the energy unit is in kilojoules, and per 100 milliliters he gets 129 kilojoules. So let's just talk about that really quickly. We spoke about joules, but what is this story now about the kilojoule? So whenever you see the word kilo, it means 1,000. So for example, kilogram means 1,000 grams. Kilometer is 1,000 meters. And so similarly, kilojoules is 1,000 joules. So when we see this measurement of 129 kilojoules per 100 milliliters, this tells us in joules that it's 129,000 joules per 100 milliliters. Okay, so that concludes today's video lesson on the section. I'm just going to go through a couple of problems with you guys, and I'm not really going to leave too much homework here. I think just activity 4. So I'm going to go through activity 2 on page 133, and I'll go through each of these questions verbally. So once again, maybe write these questions down in your book, and then you have some study material. So there's only one question here. It asks, identify the type of potential energy in each of the photographs below. So 1A shows a man holding a spring, so that would be elastic potential energy. 1B is a boy pulling back a catty, that would also be elastic potential energy. C is interesting, there's a candle burning, and this would be chemical potential energy. The wax is burning, providing fuel for the thermal energy. Next we have D, that is a car battery, and that's also chemical potential energy. E looks like a combination of both. There's a boy that's up in the air after he's jumped on the trampoline, and he has gravitational potential energy. And then there's another little boy who's bouncing on the trampoline, and the trampoline, being made of an elastic material, has elastic potential energy. F looks pretty straightforward as well. This is a seesaw, and the boy that's up in the air has gravitational potential energy, and this will help him lift up his partner. So yeah guys, that concludes today's video lesson. Thanks for watching, and once again, if you're struggling with any of these questions, please message. Take care.